Welcome to the next video in the Discrete Math video series, and here we're going to solve this exercise. So we start off by writing down the left-hand side, and we're going to argue that that is equivalent to this other formula. And here I'm using basically the only formula that I have written down for the biconditional. So in a certain way, there's kind of like no choice as to which equivalence to use because I'm pretty much sticking to one equivalence for the biconditional, and I'll ultimately also only use one equivalence for the conditional that we'll see in just a second. And the book contains several different identities for the conditional, but I'm going to use just this one that I wrote earlier, and you'll see it used here. By the way, in this one step, I'm going to apply two equivalences, right? I'm going to apply the equivalence for each of the conditionals in a single step in your own class. If you're taking a class at like a university or something like that, then they might, if they're being very tedious, they might require you to actually do that in two separate equivalent steps. But just, for the sake of speed, I'm doing it in a single step right there. Next, I'm going to distribute. So you can see I just highlighted in red and then drew an arrow indicating the distribution that I'm about to do. So, so I'm taking that whole thing, neg p or q, and I am using the conjunction distribution, right? That's a formula, and it's a conjunction on the outside with a disjunction on the inside. So I'm distributing it over to the first disjunct, and then I'm taking it and again distributing it over to the second disjunct. You can see this indicated in the green highlighting. Now, in the next step, I'm going to, I want to do a distribution, but I can't do it immediately, technically, right? Again, this is kind of a tedious concern, but I need to use commutativity first. So that's what I'm doing here is I'm swapping around the two things on either side of the conjunction in each of the terms. So I'm doing two applications of commutativity at the same time, but I'm doing this just so that I can be in a position to do distribution on the next line. That's why I chose to do this. And so here I'm going to go ahead and do distribution, right? I'm going to take that negation Q, and again, right, that's a conjunction on the outside of a disjunction, so I'm using that the distribution law. You can see indicated in yellow what is getting distributed where, and then in black, I'm going to indicate the other part of the distribution, and then I'm going to do it all over again, right? So this is really four different steps of distribution in a single line. Or sorry, not four steps of distribution, two steps of distribution in two places, even though it generates four terms. But okay, so where do we go from here? Well, I noticed that there is this negation Q, conjunction Q part, and that seems like a good candidate for the negation law that says that if you take a formula and its negation and you form their conjunction, that is equivalent to just the false symbol. And then I do it again in the next term. Now, I will point out that actually this may not be perfectly valid because technically you're supposed to have the negated formula on the right-hand side of the conjunction. So maybe I really need to apply commutativity first on that first one and then do the negation law, but I don't know, that's just so much like rewriting of all this stuff. I find these problems kind of tedious and annoying, so I'm just going to try to get through them quickly. But okay. What I've just done here is I've applied the identity law on the left-hand side because that says that if you have any formula disjunction F, then you can just drop the disjunction F. On the right-hand side, I applied commutativity to put the F on the appropriate side. Now I can apply the identity law, I think, again. I'm also using commutativity to swap the terms around just because I know that's what the answer is supposed to look like. And I'll do commutativity one more time just to swap the terms around inside the parentheses at the end there, just to make it look exactly how it's supposed to look at the end. And we're done.